Today, we're going to learn about Quicksort, a fast and efficient sorting algorithm based on the divide and conquer principle. Quicksort works in 3 steps. First, choose a pivot. The pivot is an element that helps divide the array. You can pick it randomly or use the first or last element. A good pivot reduces recursion depth, making sorting faster. Second, partition the array by splitting it into 2 parts. The left part contains elements smaller than the pivot, and the right part contains elements larger than the pivot. The pivot ends up in its final sorted position. Third, recursively sort the 2 parts. Repeat this process for each part until every subarray has just 1 or no elements, and the array is fully sorted. Let's look at an example with the array 22, 7, 12, 15, 1, 6, 8. We'll pick the last element, 8, as the pivot. We use the Lomuto partition algorithm. First, initialize 2 pointers. Pointer I starts at -1, tracking elements smaller than the pivot, and pointer J starts at the first element and compares each to the pivot. Now, process each element. First, 20 is greater than 8, so do nothing. 2 is smaller than 8, so increment I to 0 and swap 2 with 20. Next, 7 is smaller than 8, so increment I to 1 and swap 7 with 20. 12 and 15 are greater than 8, so skip them. 1 is smaller than 8, increment I to 2 and swap 1 with 20. Finally, 6 is smaller than 8, increment I to 3 and swap 6 with 12. After processing all elements, I is at position 3. Now swap the pivot, 8, with the element at I plus 1, which is 15. The array becomes 2, 7, 1, 6, 8, 20, 12, 15. The pivot, 8, is now in its final position, splitting the array into 2 parts. The left part contains elements smaller than 8, and the right part contains elements larger than 8. Repeat the same steps for both parts until the entire array is fully sorted. Quicksort is efficient because it splits the array into 2 parts with each partition, making recursion depth proportional to log n. At each recursion level, operations take O(n) time. Therefore, the average time complexity is O(n) log n. However, in the worst case, such as when the array is already sorted, Quicksort's time complexity can degrade to O of n squared. Here's the pseudocode for Quicksort. The Quicksort function calls the partition function to find the pivot's position, splitting the array into 2 parts. Then, Quicksort is recursively applied to each part.